Hello and welcome to my presentation on prompt engineering and how to write effective prompts. Let's get started. All right, so prompt engineering is a very pragmatic usage of artificial intelligence or AI, and it's really an art and a science of designing and refining inputs or prompts for an AI model, such as a large language model like ChatGPT or Gemini, to produce a desired, accurate, and high quality output. In other words, using AI to get more accurate results of what you really wanted. It is an examination and some tips on using more effective prompts to get better results out of AI systems. I'm going to summarize those tips into 5 categories that I have created. Some of these could be visualized in a Venn diagram rather than as distinct categories. Specifically, what I mean is you could combine them. But the 5 categories I have identified are: 1, the task, the core directive that tells the AI what task to perform. For example, summarize, write, translate, or generate code. 2, the context, the background information or the specific details to help the AI understand what scenario it is helping with. 3, the constraints, the rules or the parameters to limit the scope and the format of the output. For example, in 100 words, or adopt the persona of a historian, etc. I would certainly accept the argument that context and constraints are 2 sides of the same coin that are really giving the AI a specific directive. 4, examples, providing examples or references of the desired input-output behavior of the format, the style, the process, etc. And 5, the iterative process, the repeating of the prompting for continual improvement. These are the 5 tips that will formulate an effective prompt. All right, so let's go through each one, starting with task. So in prompt engineering, this is the core directive, telling the AI what task to perform by adding action words or tokenizing your input values for the AI to incorporate. This is where most of us start with large language models. We write a prompt in a task-based format. So what most of us start with when using AI, we give those instructions and tell it where we want the AI to do or where we want it to go. We want the task prompt to be clear, to be specific, and to define a format, how you want the output organized. So here's some examples. Analyze the symbolism of the green light in The Great Gatsby in 1 sentence. Calculate the final velocity of a 2-kilogram object dropped for 3 seconds, ignoring air resistance. Debate the primary causes of World War I, for example, nationalism versus militarism, as a 2-point bulleted list. Diagram the process of mitosis using 4 simple labeled steps. And generate a C++ function header named isPrime that accepts 1 integer. The second tip is context. This would be background information or specific details to help the AI understand the scenario or frame the response. The more context you give the AI, which could include the tone, the style, and the perspective. Taking that to the next level, you can also ask the AI to role play when it responds. This can include both role playing the AI being a specific speaker and telling the AI to role play who the audience is, so both the source and the target. Let's look at some examples. Act as a lead journalist for a newspaper. Writing should be punchy, slightly skeptical, and written for a highly educated audience, not for scientists. You are a high-energy motivational coach who specializes in helping entrepreneurs achieve peak flow state. You are a veteran fantasy writing novelist known for meticulous world building, high-stakes dialogue, and verbose descriptions. Describe a smartphone as if it were a newly discovered mysterious artifact in a sprawling medieval fantasy setting. The third tip is constraints. As I said, constraints is the other side of context. So if context gives it the specific role of the speaker and the audience, constraints limits the amount of output that the artificial intelligence generates. It's rules or parameters to limit the scope and the format of the output by adding rules or specifics to the prompt, and so that the prompt has some parameters to narrow or widen the response output. So you're dealing with scope and you're dealing with format. You add those constraints to balance the depth and the simplicity, the depth and or the simplicity of the response, depending on what kind of answer you're seeking, giving open-ended versus close-ended prompts. So let's look at some examples. To add to the prompt the following tokens or the following words. Keep it under 100 words. Explain quantum computing to a 5th grader. Describe the causes of the French Revolution using exactly 3 bullet points and adopt the persona of a historian. Write a persuasive paragraph on remote work. The final sentence must be a rhetorical question. Compare and contrast the internal combustion engine and an electric motor using a 2-column markdown table. Write a function header in Java for a method named calculateArea that accepts 2 integers. Do not include the method body. On the next level, in terms of constraints, you can incorporate a prompt engineering technique known as the chain of thoughts engineering, and also we'll look at the tree of thoughts engineering, and we can even synergize both of those. But let's start with the chain of thought. The chain of thought engineering, or COT, is a technique which asks AI to essentially show its work, to basically give you the internal steps of the reasoning it came up with. You add phrases into the prompt engineering, like for the AI to show the steps in reasoning, explain with a step-by-step set of instructions, or justify your steps in the answer. So let's look at some examples of chain of thought engineering. Calculate the force required, justify your choice of formula, and show all substitution steps. Explain the major causes of the Cold War, list each cause, and show the logical link to the resulting tension. Solve for x in 3 bracket x plus 2 equals 15. Explain with step-by-step instructions as if teaching a peer. Balance the following chemical equation. Show the steps for adjusting the coefficients. And trace the output of this recursive function. Show the steps for each function call. Also, another next step you can do with constraints is the tree of thoughts technique. It uses branching techniques like looking at a tree upside down or a tree-like structure and exploring multiple paths of reasoning at each step. Explore the promising ones, disregard the weaker ones. Let's take a look at some examples. Draft a story opening. Generate 3 hooks, evaluate which is strongest, and then write the opening. Optimize this loop. Propose 2 alternative algorithms, justify the faster one, and provide the final code. Set a new marketing budget. Define 3 cost-cutting options. Assess risk for each, and select the safest one. Analyze this circuit. Postulate 3 possible failure points, rank them by likelihood, and identify the most probable one. Another next level is to synergize these 2 prompt engineering techniques. So the chain of thought, COT, and the tree of thoughts, TOT, putting them together. So let's take a look at how you could do that. You could prompt to generate multiple thought paths, which is tree of thoughts. You could prompt to elaborate on each path, which is a chain of thought within a tree of thought, and explain the step-by-step reasoning. You could prompt to evaluate and select tree of thoughts, and by assessing these detailed paths against given criteria, you could prompt to justify the selection, which is chain of thoughts for the tree of thoughts, why a particular path was chosen over others, and you could prompt to detail the final steps, which is chain of thoughts for the final answer, and present the solution with its final sequence of steps. Let's take a look at examples. Write a persuasive essay hook, which is your task. Generate 3 strategies. That's your tree of thoughts. For each, outline the rhetorical steps and select the strongest and explain why, which is your chain of thoughts. Another example is to prove the triangle congruence theorem, which is your task. Propose 2 proof methods, which is branching tree of thoughts. For each, show the step-by-step derivation, which is the chain of thoughts, explaining its thinking. Select the simpler proof and explain your choice, which is, again, the tree of thoughts branching, converging. And finally, refactor this code, which gives you your task and you're providing it an example. Propose 2 logic approaches, so that's tree of thoughts. For each, detail the steps and justify why one is faster. So that's your chain of thought, justifying and showing its steps. So that's obviously a next level prompt engineering technique where you really have to craft an effective prompt. All right, the 4th tip, examples. To provide examples, to provide templates or references to give guidance to the desired input-output behavior, looking at format, looking at style, looking at process, etc. So doing this especially is effective for demonstrating a specific style, a specific format, or a specific task logic. This is sometimes called few-shot prompting, meaning you're giving a few different shots of how you want your answer to look, or snapshots. For a next level, you can use what's called multimodal prompting, when you attach or include other media or different modalities other than your text prompt, such as providing an image or a picture file, uploading it to the large language model, providing audio files, providing a video file, providing a Word or a PDF or an Excel or a PowerPoint file, or a code file in the case of code. You can even provide it with links to websites that are part of the multimodal prompting. Here's a couple examples. Identify the core trait of a literary character. For example, character Juliet trait, passionate, character Hamlet, trait focused. So you hear in this one, you're providing it in textual form, the example you're looking at. State the immediate consequence of a historical event from the attached document. And then you would attach a Word document, a cause and effect history worksheet. And finally, identify the lab tool's function from the image. And you would attach an image of something like, for example, a beaker, so that it has a context and it has an example. The final tip is the iterative or the repetitive or the looping process. AI models are built on a concept known as backpropagation, which is the whole idea that it keeps retraining itself. So we can tap into this nature of the AI in the prompts we write. So we experiment, we iterate on our prompts, we evaluate out of the outputs, and is this the output that you wanted? If the output is not satisfactory, then prompt again. Repeat, iterate, prompt off of the previous prompt. So 1, we could revisit the prompt engineering framework. So after providing the initial prompt, should I pick a different action wording from my initial task? Should I add more constraints or less constraints? Should I add more or less context or modify those? Did I give any examples or should I give different ones? And should I repeat this process again? So in the first tip in iteration, it is to revisit the framework or the 5 tips I'm providing. Second tip in iterative process is to separate the prompt into shorter sentences. AI work on a tokenization factor. They take your prompt and tokenize the words. Think of it like this. The way we talk to other people, we don't like to word vomit to others. We often talk in shorter bursts. So maybe you should treat AI the same way you talk to people, right? Sometimes it can understand us better if we provide it in bursts, but that will require you to iterate off of your previous prompts. More obvious ones are just try different phrasings. Same prompt written a different way. And read in response to follow-ups. So read what the prompt output is providing so that you can iterate off of what it's saying. On the next level, leverage one AI model with another to improve on each other. So for example, put the response of a ChatGPT prompt into a Gemini prompt as an example. Have Gemini evaluate what ChatGPT came up with and look for improvements. Another next level is what's called meta prompting, where you ask AI to write the prompt for you. So let's take a look at some examples. Write a few-shot prompt to teach a student the difference between Python lists and tuples. The examples must include a short description constraint. Generate 5 tone adjectives that would be best for a prompt, asking an AI to analyze Hamlet's sanity and explain why each is effective. I need a prompt that forces the AI to argue against the use of the atomic bomb. Draft a prompt that includes a persona constraint. For example, respond as a post-war diplomat. And finally, I want the AI to solve, I can't say that word, a specific problem. Write a prompt that uses the chain of thought technique to ensure it shows every step of the multigram conversion. So obviously, by asking AI to write the prompt, you're going to iterate off the prompt it writes for you. Another next level is called prompt chaining, where we put the previous prompt, which might be a meta prompt, into a new prompt and ask for improvements in the way it wrote the prompt. And this is obviously an iterative process. So here, for example, on our first prompt, we would say identify the 3 primary reasons for the failure of the League of Nations. In our second prompt, we would say, using the reasons from prompt 1, propose a reform that would have solved the most significant issue. And then finally, we would chain off of that and say, write a 2-sentence summary explaining why your reform from prompt 2 likely would not have succeeded. And that's called prompt chaining. Another next level technique is called using AI agency, or an AI agent, where you write a prompt to have AI to act as a specific type of quote unquote agent and assume a specific role-playing role. And tell AI you will also be role-playing a specific role in a specifically defined simulation for a specific type of conversation. You would include in your prompt that eventually you will give the AI a key phrase or an exit scenario for the simulation. And then include in the prompt that once the key phrase is entered or once the exit scenario has been reached, the AI should summarize the conversation, suggest improvements, and provide you with takeaways. So let's take a look at an example of how this could go. So you would prompt the AI. In this case, maybe you would use something like Gemini Live or ChatGPT, where you're actually chatting with it rather than typing it, although it could be done in either way. Act as an AI agent and assume the role of a computer science professor. I will assume the role of a first-year student in one of your classes preparing for an exam. I will be asking questions and will engage with your explanations. The simulation will end when I type in the key phrase, end simulation. Upon receiving this key phrase, you will provide a concise summary of the student's main areas of confusion, strengths, and the subjects covered. Also, offer a 2 to 3 specific actionable suggestions for the student on how to improve on what we discussed. Also include any insights or observations about the simulation. So, this framework in prompt engineering and the 5 tips I've provided provides an infographic approach to looking at how, when you sit down to work with an artificial intelligence, for example, large language model, when you sit to provide that input, that prompt, what can you do to engineer a more effective output? So if you think of those 5 areas, task, context, constraints, examples, and iterative process, the effective prompt starts to take shape. Within the task, you're talking about the core directive, using action words, telling the AI what task to perform. Within context, you're providing background information or specific details to help the AI understand the scenario. With constraints, you're providing rules or parameters to limit the scope and the format of the output. With examples, you're providing those examples and those references of the desired input-output behavior. And finally, with the iterative step, you're repeating the prompting for continual improvement of your results. Within those, you can see some of the examples that we looked at, that we covered, that showed that. So again, looking at this from a infographic perspective, just seeing this as you're getting ready to write a prompt will really maybe hopefully trigger some of those specifics and really start to craft the effective engineering of an effective prompt. So I provide for you something like this, a framework, an infographic that you could have on hand when you're going to write an effective prompt. so that you can go over those 5 areas and then go into a little more specifics and some next level type concepts within the prompt engineering framework. One thing to keep in mind as we wrap up is that despite this impressive technology, AI prompts and outputs are not immune from errors. So, common errors with AIs is hallucinations. This is when the AI generates plausible sounding but false or misleading or nonsensical information that it presents as fact. This is common with large language models. They make things up based on the training data rather than retrieving and researching accurate information. There's also the problem of bias. This is when AI produce results that are systematically unfair. They're prejudiced or discriminatory against certain groups, individuals, and they reflect the underlying bias in the training data that it was trained on or the way it was designed. Okay? This includes the data bias, the bias in the training data, and the algorithmic bias when the bias is introduced in the design of the AI model or the implementation. AI is only as strong as the people who programmed it. So AI learns the same hallucinations and the same biases that we have as humans. It learns from us. Thank you, everybody, for taking a look at this presentation of prompt engineering. I hope you found it useful, and have a great day.